Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to start with a new chapter, new topic, that is system level input output. So this is the new chapter, that is system level input output. In the last class we have studied last chapter, that is the virtual memory. But now today is the starting point, today is a new week, so I am starting with the new topic, I am starting with the a new concept, new feature, that is the system level input output. But before this, as per the given schedule, as per the given module, let's take a quick review what we have covered in the last class. That is a recap of the previous class, recap of the last class, recap of the previous lecture. So let's start with the recap of the previous chapter or the previous class. In the last class we have studied about debugging techniques. This is the last class chapter, this is the last class, that is a virtual memory continue. That is, we have continued with the virtual memory concept, that is virtual memory, last topic, that is a debugger. Then we have studied about finding and fixing the bugs, that is how to find and how to fix the bug. But first of all, we have studied what is a bug and what are the types of bugs that is available for the debugging. So first topic we have studied in the last class is finding and fixing the bugs. In order to create the quality software, you need to find your bugs. That is the main important thing, that is the finding and fixing the bugs. How we can find and how we can create the quality software? By testing and by using the user's report. We can fix and we can find the bugs. The best bugs are those that are always reproducible. That is, that are reproducible, that are the best bugs. That is, we can reproduce the bugs, we can use the bugs again and again for the debugging process. Then we have studied about what are the types of bugs that is available, that are the types of bugs, that is GOTA, love, M. So we have studied multiple types of bugs depending on the time to time. That is, first of all, the first bug that we have studied is the compile time bug. The bug name is the syntax bugs, the spanning bug, the static type mismatch. So these are the types of bugs at the different intervals, at the different timings. So first one is your compile time, that is either syntax bugs, spelling bugs, static type mismatch. So these are the types of bugs that is available. These are usually caught with the compiler. Usually caught means these are usually tackled with the compiler. That is usually tackled with the compiler. That is tagged with the compiler. Then next is your design bugs. That is your next level bug. Then that is float algorithm. That is used with the float algorithm. That is used by using the, or that is done by using the incorrect paths. Then next bug that is that we have studied in the last class is the program logic bugs. This is due to the some mistake in the program logic, we can that this bug can occur. That is the program logic bugs. The next type of bug that we have studied in the last class is the memory nonsense bug. So these are the memory nonsense bugs. So these are the different types of bugs that we have studied in the last class, and these bugs are occur, or these bugs can occur depending on the system to system, depending on the program to program, depending on the application to application. So in memory nonsense bugs, there are multiple few types, like we are using null pointer, that is also memory nonsense pointer bugs. Array beyond the bound, that is we can access the elements beyond the bound, that is the array bounds. Then next bad types, suppose I am using the float int type, that is in decimal point, but I am using the int, that is int 14.5, that is also a bug, that is also an error, because we are using the decimal point but we are using the data type that is int. So that is a mismatch of the data type, that is a bad data type. Then next is your leak, that is also a memory reference or the memory nonsense bug, and these bugs are caught at the runtime. These are the runtime exceptions. Then Next type of bug is interface error. That is a communication error. That is the interface error between the modules, between the programs, between the threads. In particular with shared resources, sockets, file, memory, etc. And they are caught at the runtime exceptions. Then next is your off nominal conditions. This is also a bug that is at the off nominal conditions. Whenever there is a failure of any machinery, there is a bug that can occur. That is the off nominal condition. So failure of such type of or some type of software of underlying machinery, that is also a bug. That is a off nominal condition. Then this is one of the condition. This is one of the bug that can occur in a computer whenever there is a failure of the machinery. Then this can be code or this can be incomplete functionality. Then next bug is your deadlock bug that we have studied. That is a more than one process or the multiple processes fighting for a single resource. That is a deadlock condition. So this is next type of bug that is available in any computer system. Then we have studied what is a debugging process or what is a debugging that we are using or what is debugging. So debugging is a process in which we can find or the system can find the bugs so that system can use the resources, system can make the resources for the software engineering. That is the ideal of debugging process. This is a debugging algorithm for software engineering. That is, a debugging algorithm identify the test cases that reliably show existence of fault. That is, it can show the existence of faults. That is, we can identify or debugging technique, debugging process can identify the test cases. Then it means debugging also allows or isolate the problem to a small fragment of programs. So we have studied what is a debugging process and what is an ideal debugging process. That is, what is a debugging process that is accurate or that is appropriate for any computer system. That is the ideal debugging process. Then debugging also involves a regression testing that we have studied. That is the second last point. That is a regression test to verify that the error has really been removed without inserting new errors. That is, we can identify that if the errors are removed correctly or not. Then update the documentation when appropriate. So next last point is update the documentation, means update the documentation part, that is a written part, whenever there is a appropriate, whenever that is a appropriate. Then we also studied about the general advices. That is, what are the general advices in the debugging process. That is, first of all, try to understand as much of what is happening as possible. That is, try to understand more concept than whatever is possible. Then we also studied the general approach that error messages are generally just a vague hint and can be misleading. Don't always trust the commands document. Then we have studied what is a debugger. Debugger is a software tool that is used to detect the source of the program or script error. So debugger is a software tool, is a software technique that is used to detect the source of the program or script error by performing step-by-step execution of application program and viewing the content of the code variable. So this says debugger is a software tool, is a software application that is used to detect the source of the program or script errors. Then what is a debugger? That is a continued. It is not an IDE, that is not an integrated development environment. Then we have studied why we are using a debugger. What is a technique? No need for precognition of what the error might be. This is a flexible, that is, we can use or it allows for the live error checking. Why people don't use a debugger, that we have studied this one. And then we have studied the multiple debugging techniques, that is execution tracing, that is, or that includes the running, printing, tracing, single stepping and simulation. Then interface checking, then assertions, then skipping code. Next is your other types of or other functions of debugger. That is, what are the other functions of a debugger? What is the role of a debugger? That is disassembly, execution tracing, stack tracing, symbol watches. Then what is a disassembly? That is a basic form of debugging. Then execution tracing, we have studied symbol information, debug, release font. So we have studied multiple topics about the debugging with the book with the help of PPTs also. Now today I am going to start with your next topic, that is the today's topic, that is system level input output. This is a new topic, this is a new chapter for the today's class, and this is one of the chapter that is not related or that is not attached to the previous chapter. This is the unique chapter, that is the new concept that is not related to any concept. Now system name is system level input output, as the name advice. So let's start some basic introduction or with some basic introduction. System level input output, that is at the system level whatever the input is going, whatever the output is coming, that comes under the system level input output. So in computer system, whenever we are giving any inputs with the help of keyboard, with the help of mouse, and then process the input and then at last generates the output, that process or that part is known as the system level input output. In this chapter there are 10 topics. Now let's take quick review of what is covered in this topic or in this chapter. First is your Unix input output, that is how we can give the input and how we can generate the output in the Unix, that is in Unix operating system. That is your Unix input output. Then next is opening and closing the files, that is how to open and how to close the files in a Unix operating system. Then how to read and write the files. So one is open, how to open, what is the command available in Unix to open the file, how we close the file or what is closing a file, and what is the key, what is the command for closing the file. Then next is your reading, that is how to read the file, how to read the content of the file. Suppose my cursor reaches to the end of the location, then how we can search or how we can read, how we can write the files. That is a reading and writing the files. Then next is your robust reading and writing with RIO package, that is RIO package. So that is the next concept, that is how to robust or what is the use of the reading and writing with the RIO package. Then next is your reading file metadata, that is how to read the file metadata that is available. That is also a category or that is also a system level input output. Then sharing a file, that is what is sharing a file and how we can share the file and what is the advantage whenever we share any file with multiple users in a network. Then next is your input output indirection, that is input output redirection, that is how we can give the output of one into the input of another, that is the input output redirection. Then standard input output, that is what are the standard techniques that is available for input and output, like printf, scanf, getch, fch, that is a standard input output. Then putting it together, which input output function should we or should I use. Then at last summary. So these are the 10 topics that is covered in this topic, and this is very easy topic, that is very small topic also, very small chapter also, and very interesting as well as the easy, because all the process or all the task is going in towards the inputting, outputting, that's all. That is how to give the input and how to generate the output. Now let's start with this topic. Let's start with some introduction first of all. This says input output. As you know, what is the input output? It is a process of copying the data between the main memory and the external devices such as disk drive, computers, terminals and network. That is, it is a process or it is a way of copying the data. Copying means copy the data from one memory to the another memory. That is, it is a process of copying the data between the main memory and the external devices. Suppose I am writing one computer or I am writing one instruction into the main memory. That is the process of copying the data between the main memory and the external devices such as disk drives, terminals and network. So whenever we copy the data between the main memory, between the external devices like floppy disk, hard disk drive, network, that is known as the input and output. That means input is given to the memory and output is generated from the external devices. An input operation copies the data from the input output device into the main memory. As I told you, it copies the data from the input output device into the main memory, and output operation copies the data from the memory to a device. So this is a process of copying the data from the main memory to the external devices. It means first of all fetches the data from the input devices and store into the main memory. Then output, using the output that copies the data from the memory to a device, from the memory to the external device. The next point says all the languages runtime system provides high level facility, high level flexibility for using the system. That is for using the for performing the input and output. Then next point says, for example, ANSI C provides the standard input output library. That is, C language provides the standard input output functions such as printf, scanf that performs the buffered input output. In the same way, C++ provides the same functionality, that is printf and the scanf, by using the operators. One is put to operator and one is get from operators. Put to is used for giving the output, that is putting the output in the in some standard, and get from is the way to get the data from the memory. So get from is similar to the scanf and put to is similar for the printf in the C language. That is in simple terms, input and output means giving the input and taking the output. Then next line says, on Unix system these high level input output functions are implementing using system level Unix input output functions that is provided by the kernel. So this is the main topic, this is the main agenda for this topic, that is using the input output in the Unix system, in the Unix operating system, how we can give the output and how we can generate the how we can give the input and how we can generate the output. Most of the time the high level input output functions work quite well and there is no need to use Unix input output directly. So why bother learning about Unix input output? Means what is the advantage or what are the features that I am using, or that is what is the main reason why I am using the Unix input output, or what is the advantage, what is the benefit that is required. So first benefit or the first advantage is that whenever or understanding the Unix input output will help you understand other system concepts also. That is, if I am understanding or if I am able to understand the Unix input output, then it helps to understand me or it helps to understand any user other system concepts. That is, if I have a knowledge of the input output of the Unix, then I am capable to understand the system concepts also. Input output is integral to the operation of a system. As I told you, input output is required or very crucial part of the system, operation of a system, and because of this we often encounter circular dependency between the input output and the system ideas. For example, input-output plays a crucial role, key role in process creation and the execution. Conversely, process creation plays a role in how files are shared by process. Thus, to really understand input-output, you need to understand the processes and the vice versa. That is, all these are related. That is, input-output and the processes are related with each other. Whenever we understand the processes, then we are comfortable with the input output, and whenever we generate the input output, I am comfortable or we are comfortable with the system. We already touched an aspect of input output in our discussion of the memory hierarchy. We already discussed about the memory hierarchy, that is linking, loading, process and the virtual memory. Next point says sometimes you have no choice but to use the Unix input output. So this is also the main reason and one of the crucial reason, that is there is no other need or there is no other criteria except the Unix input output. So it's a mandatory condition that I should use, that is, this is a mandatory condition that I should use the Unix input output. So this says sometimes there is no other choice but to use the Unix input output. There are some important cases where using high level input output functions is either impossible or inappropriate. For example, sometimes the standard input output provides no way to access the files, metadata such as file size, file creation time. So there is requirement or there is a need for using, or there is a need, then we are using only Unix input output. So this is the condition where we have a choice, we have no choice for using or except using the Unix input output. Then this chapter generates or introduces the general concepts of the Unix input output and the standard input output, and shows how to use them really or reliably from your C programs. Besides serving as a general instruction introduction, this chapter also gives a firm foundation for our subsequent study of network programming and concurrency. So this means this paragraph, first of all we have studied that what is the input output, what is the standard input output, and what is the use, why we are able to understand or why we are studying the Unix input output. That is also the next concept, that is understanding the input output helps to system concepts. Or next point says we have no choice but to use the Unix input output. This chapter gives you a brief idea, general concept of the input output and the standard input output. Now let's start with the new topic. Let's start with the basic topic, that is Unix input output. But before this, let's take a quick review what is covered in the slides. Because the main reason is that whenever you see the slides, that gives a clear impact, because that slides gives you a crux, not a full book. Because if I'm reading book, there is a lot of time that is required, but if I'm using the slides, that is more comfortable to understand the concept in an easy way. So let's start with the slide. This is chapter number 10, that is system level input output. That is at the system level, what is the input and what is the output. These are the topics that is covered in this, that is the system level input output. First topic that is covered is Unix input output, then robust reading and writing, then reading file metadata, sharing file, input output indirection or redirection, then standard input output. First slide is a typical hardware system. This is a typical means the most basic or the common hardware system. That is a typical hardware system. First of all, there is a CPU chip, there is a register file, there is a bus interface, input output bridge, main memory. So first of all, there is a CPU, that is central processing unit. There is a main memory, memory bus, then input output bridge. Memory bus is required between the main memory and the input output bridge. Then this is the expansion slots that is required, such as network adapters, that is the extra one that increases the functionality of the main memory. Then there is a disk controller that controls the disk. Then this is the input output bus that provides the interface between the input output bridge, the CPU chip and the main memory. Then this bus also controls or also includes the USB controller, graphics adapter, disk controller that is attached to the disk. So this is a typical hardware system. If you see or if you imagine that we are able to simple understand what is a system, but that's not a system. That is also contain or that contains some hardware parts. So this is the internal hardware parts, that is whenever we use a system, these are the hardware parts that is included. So this is a typical hardware system. There is a CPU chip, there is a system bus, memory bus, expansion slot, disk controller, graphic adapter. That is all is internal, or that is all attached to the one place. That makes the system. Next, how to read a disk sector, that is the step 1. That is how we are able to read, or how computer able to read the disk sector. This says CPU initiates a disk read by writing a command. That is whenever we use a control or central processing unit that initiates a disk read by writing a command, logical block number and the destination memory address to a port associated with the disk controller. That is, whenever CPU needs a disk or initiates a disk read by writing a command, they need a logical block number, destination to a port address. That is, this is a CPU chip that or CPU initiate a disk read by writing a command. So first of all, but the bus interface it attached to the disk controller directly, and then data it fetches from the disk that is provided to the disk controller, and then in turn disk controller provides the data to the bus interface. Bus interface provides the data to the registers, and registers provide the data to the CPU. Disk controller reads the sector and performs a direct memory access and transfer the data into the main memory. So this is the role of the disk controller, that provides or that reads the data and performs a direct memory operation, direct memory access of the disk controller, so that the data will be directly going to the main memory. Next, when the DMA means direct memory access. When the DMA transfer complete, that directly goes data has gone to the main memory, the disk controller notifies the CPU with an interrupt. That is, the disk controller notifies with the interrupt, that is, it asserts a special interrupt pin on the CPU. That is also a part of the disk, or how to read the data from the disk. Now, next is your Unix files. Means what are the types of files that is available in the Unix. That is, a Unix file is a sequence of m bytes. That is, if I am using 1 byte, or if I am using one file of a Unix that contains, or that is a combination of multiple bytes. That is, it is a sequence of bytes. Next point, this is the example, that is, it is a sequence, it is a combination of the m bytes. Then next is a example. This is the example. There is a file that is b1, b0, b0, b1 till bk, then bm-1. Means any type of file that is a sequence, that is in sequence. There is no alter between the sequence. Suppose if I am using b0, b1, then next one should be, or then next one must be b2, not the b3, because that maintains a sequence. That is, from after b1 it is b2, not the b3. So Unix file is in a sequential manner. That is, if I am able to access the sequential manner, that is a Unix file that consists of m bytes, b0, b1, bk, bm-1. Then Next point says all input output devices are represented as file. That is, all the input output devices are represented by using the files. That is, any input output device, keyboard, mouse, joystick, that are represented by the files, or that are represented as the files. For example, this is a file, that is /dev/sda2, that is a user disk partition. Then /dev/tty2, that is your terminal. So every input output devices in the Unix system is represented by the file. Even not the input output devices, even the files, even the folders, and everything is treated as a files in the Unix. Next says even the kernel is represented as a file. As I told you, everything in the Unix is represented or treated as a file. This is also treated as a file, that is starting with the device directory, that is dev, then kmem, that is kernel memory image, that is your kmem. Then next is your proc, that is a kernel data structure, that is also a proc, that is also a part. Why this is a very important part? Because kernel is represented as a file. Means every system of the Unix is represented as a file, whether it may be input output devices, whether it may be kernel, whether it may be folder, it may be sub file. Then next is your regular file types or Unix file types. That is the next topic, that is what are the types of files that is available in the Unix. The first type of file in the Unix is a regular file. Regular file means a simple file that every user is able to use. That is either a binary or the text file. If this is a binary file, then all the data is written in the binary format, that is in zeros and ones. But if it is a text file, then the data is written in a text language in a English statements. That is also a text files. Then next point says Windows does not, or Unix, sorry, not Windows. Unix does not know the indifference. That is, it does not know the indifference. What is the indifference between the regular file, between the binary or the text file? Then next file that is used is a directory file. That is which I told you that every folder is also a file. That is a directory. So folder is also known as directory, as I told you in the first class or the second class of the session. So directory file is a file that contains the name and the location of other files. So directory is a folder that contains some other folders, other files also. So that contains, or a file that contains the name and the location of their files is known as the directory files. Names means the name of the file as well as their location, where it should be saved. That is your location of other slides. Then next is your character spatial and block spatial files. So one is your character spatial file, that is the file that contains only the spatial characters, and the file that only contains the spatial blocks, that is a spatial block file or the block spatial file, and the character spatial files. This is terminals, that is a character spatial, and the disk, that is a block spatial. So one is your terminal, that is if I am using the terminal, that is your character spatial, and I am using the disk, that is your block spatial. Then next one is your FIFO, that is first in first out, that is a name type. This is the file system, or this is the file type that is used for inter-process communication. What is inter-process? That is communication is lying between one process to another, that is internal to the computer, that is a internal inter-process communication. So a file size, FIFO is also a category of the file, that is a file that is used for the inter-purpose communication. Then next is your socket. Socket is also a file type that is used for network communication between the process. So FIFO is used for the inter-process communication, socket is used for the network communication or used for the network communication. So one is also the interprocess, one is the network communication. So these are the Unix file types. One is regular file, one is directory file, one is classic special and the block special files, one is FIFO, one is socket. The elegant mapping of the files to the devices that allows the kernel to export simple interfaces known as the Unix input output. As I told you, whenever there is a mapping, whenever there is a comparison between two files, between two modules, between two kernels, in this the kernel allows you to export simple inferences, and then that is known as a Unix input output. That is mapping of the input to the devices, that is the kernel, to export the simple interface known as the input output or Unix input output. Next is your key Unix idea, that is what is the basic idea, what is the main motto. That point says all the input and output is handled in a consistent and the uniform way. That is the key Unix idea. That is all the system, all the inputs, all the output is handled in a consistent and the uniform way. That is, it is available in a consistent way and the uniform way. That is the key Unix idea. That is all the input and output is treated as a file. Then what are the basic Unix input output operations? That is also known as the system calls. So what are the operations or what are the basic system input output operation, basic Unix input output operations? First is opening and closing a file. This is the syntax, that how we are using to the open command to open a file, and how we are using the close command to close a file. And this is the syntax, that is open, then there is a curly braces, then close, there is a curly braces. Then next point or next operation is that changing the current file position. First operation of the file is that, or the Unix of output operation is that, first one says opening and closing the files. The next operation is changing the current file position. That is done by the seek command. That is using, or that is used by using the lseek command. That is not discussed. Then because in your course only the first topic is there, that is how to open and how to close the file in the Unix input output by using the commands, by using the computer. Then next is your reading and writing the data. That is one of the basic operation, one of the basic Unix input output operation is also reading and writing the data. For reading purpose it is using the function, that is a read function, and for writing purpose Unix also provides a next function, that is a write function. So in simple terms, written as a read parenthesis write parenthesis. Now next is basic input output operations in detail. That is how to open a file, that is opening a file. But before this, let's take a quick review about in the book, that is something is there in the new in the book or everything is same. This is the same. A Unix file system or Unix file is a sequence of m bytes, that is 0, 1, 2, k and -1. Next point says all the input output devices such as network, disk and terminal are modeled as a file, and all the input output is performed by reading and writing the appropriate limit. This says this elegant mapping of devices to files allows the Unix kernel to export a simple low-level application interface known as the Unix input output. That is the kernel uses the method, or the Unix uses the kernel to export a simple low application software that is done by using the Unix input output, and then that enables all the input and output to be performed in an uniform and consistent way. Then how to open a file, that is opening a file. An application announces its intention to access an input-output device by asking the kernel to open the corresponding file. First step is open the corresponding file. the kernel the kernel the kernel returns a small non-negative integer that is known as the descriptor that identifies the file and all the subsequent operations on the file. That is, if I am using the file, then how to recognize the file, how to separate the file by using the file descriptor or the descriptor that identifies the file in a subsequent operation or subsequent location on the file. Then next paragraph says each paragraph created by the Unix begins life with 3 open files, that is standard input, standard output and the standard error, and the input is represented by the descriptor 0, output is represented by the descriptor 1 and the error is indicated by the descriptor 2. The header file, that is unistd.h, defines the constant, that is standard input output file number, standard output and the standard error, that is stdin, stdout, then std error, that is stderr, which can be used instead of explicit descriptor values. Then next point is that changing the file positions. So this is the next process, that is changing the current file position, that is change the file position from the K to the next one. This says the kernel maintains a file position, that is K in the initially, that is it maintains the file position K initially at the 0, that is it starts with the 0 location. So suppose I want to access the first location, that is the mandatory condition, that is in Unix input output the kernel maintains a file position, that is K initially at the 0 for each open file. The file position is a byte offset from the beginning of a file. An application can set the current file position K explicitly by performing a seek operation. This is a way how we can get the current file position. Suppose I want to know that what is my current file location or what is my current file position, that is represented or that is used or that is how we can get by using the seek function, by using the seek operation. Then next attribute, next operation or the next input output operation is reading and writing the files. That is a read operation copies n greater than 0 bytes from a file to the memory. That is how we can read. We can read the data from the files to the memory. Starting at the current file position, that is K. So it starts with the current file position, that is K, then decremented the K by the n. Given the size and the read operations, a condition known as the end of the file. This means the process or the Unix searches the file till it reaches the EOF, that is till it reaches to the end of the file, which can be detected by the application. There is no explicit EOF character at the end of the file. Similarly, in the write operation, so one is read operation, that is inserting the files from the or accessing the files from the memory. Then write operations, whenever n is greater than 0, that is there is some byte in the memory, we get the bytes from the memory to a file, means we assign the bytes from the memory to a file, starting at the current file position, that is K, and then updating the K. Then next is your closing the file, that is next operation or the next input output operation is how to close the file, that is closing the file. This is when an application has finished accessing a file, that is when application has finished or finished performing the task for accessing a file, it informs the kernel by asking it to close the file. So this is the last operation, next operation that is used in the system level input output, that is closing the files by asking it to close the file. The kernel responds by freeing the data structure it created when the file was opened. That is, it frees the data, or it frees the data structure, that is, it releases the data from the memory that is created when the file was opened, and restore the descriptor to a pool of available descriptors. This is the most important line. That is, whenever the file will be closed, the kernel role is to free the data structure, that is releasing the data from the memory, releasing the data structure when the which was created when the file was opened, and also restore the descriptor. As I told you, descriptor is a method to indicate the operations in a or subsequent operations on a file. So whenever the file has finished, free the data, so there is no use of the descriptor, so that is then restore the descriptor to a pool of, that is put all the descriptor in a pool of available descriptor. Then when a process terminates for any reason, it may be n number of reasons, then the kernel closes all the open file and frees their memory resources. This is how to, or these are the various operations of the Unix input output. These all operations is going to start, or I will cover in this chapter in detail. That is how to change the file condition, how to change the file position, reading, writing, closing. That is the these are the topics that is covered in this topic in this chapter in detail. So let's start with the first topic. Let's start with the first module, that is opening and closing the files. So let's start with the opening and closing the file. That is how to open and how to close the files in the Unix. That is a part of the input output operations. This says a process open an existing file or creates a new file by calling the open function. So it depends on the functionality to the functionality. That is, what is the requirement of the user. Depending on the requirement of the user, a process opens an existing file or creates a new file by using the same function name, that is the open function. So we can either open the existing file or we can either create the new file in the same way as we have studied in the MS Word, Excel. Then that is, we can also create the new document and we can also open the existing document by using the different commands, that is Control O, Control N. Control O is used for opening an existing file and Control N is used for creating a new document. So in Unix, this task is performed by using the open function. These are the header file that is included, that is hash include sys type.h, that is the sys system type.h, then sys stat.h, that is statistics.h, then fcentral.h, then uses the command, uses the file, that is uses the function that is of int open, that is of return type int, open is the function name. These are the arguments. One is file name is of character type, that is a pointer, that is it stores the location where the file will be stored, or it stores the memory address where the file name will be stored, that is a char pointer file name. Then next argument is int flags, that is of integer type. Then next is mode t mode, that is the next type, that is a mode t mode. It returns the new file descriptor if OK, -1 or error. So if there is a code, this is OK code, it gives or it returns the file descriptor, or if there is any error, it gives only -1. This says the open function converts a file name to a file descriptor. That is, it converts the file name to a file descriptor and then return the descriptor number. The descriptor return is always the smallest descriptor that is not currently open in the process. So these are the explanation, that is it converts, that is the open function converts a file name to the descriptor and gives the descriptor number. The descriptor return is always the smallest descriptor and so on so on. The flag argument, this is the flag argument indicates how the process intend to access the file. So this flag is used to indicate the, this is one of the important point that is comes in the assignment also. That is this is the argument, or this argument indicates how the process intend to access the file. So flag is used for the modes that is required for accessing the files, for access the files. That is, there are three types of mode, or three types of mode that is available. One is O random only, or one O read only, that is RD only, that is for reading purpose, that is a reading only. Then O WR only, that is the only for writing purpose, that is a writing only. Then O read write, that is RDWR, that is for both for the reading as well for the writing. So flag indicates the file to access, or the method to access the file. That may be reading only, that is the file is read only. That may be writing only, that is the file is only used for writing purpose. And one is both for reading as well for writing. So this is the next argument. First argument, open function that converts a file name to a file descriptor. Next, flag that is used to indicate how to, or how the process intend to access. Then for example, here is code to open the file. This is here is how to open an existing file for reading. That is, these are the permission bits. This is the different. This is how to open. This is using any variable, that is for example fd. Then uses the open function, uses the file name, that is foo.txt. This is the file name, this is the extension. File name is foo and the extension is txt. Then uses the argument, that is O read only, that is a RD only. Then O. The flag argument can also be ordinary with one or more bits mask that provides the additional instruction for writing. That is, this also provides a O that is used with the additional purpose for writing. That is O create, O trunc, O append. These are the multiple instruction that is used, or these are the additional instruction that is used for writing purpose. O create, if the file does not exist, then create a truncated, that is the empty version of it. What is truncate? That is, if the file already exists, then truncate it. Append, that is before each write operation, set the file position to the end of the file. For example, this is the way how you can open the existing file with the process of appending the file. So this is the different method, that is in argument we can define multiple methods, we can define multiple modes. That is O randomly, that is used with the O create, O trunc, O append, that is the O append. The mode argument specifies the access permission. So this is the mode argument that specifies the access permission of new files. The symbolic name is represented in figure 1. This is the symbolic names, that is if I am using s_irusr, that is user on, the owner can read the file. That is, next one is IWUSR, that is owner can write the file, or the user can write the file, then execute the file. That is R is used for read, W is used for write, and X is used for execute. Then IRGRP, that is members of the owner group can read the file. In the same way, WGRP, that is group can write the file. In the same way, group can execute the file. This is RAuth, that is others can read the file, others can write the file, and others can execute the file. These are the various specifier that is also used. This says when a process creates a new file by creating the open function with the same mode argument, then the access permission bits are set to mode and the umask. For example, suppose we are giving the default values for the mode. This is the example. So this is means that gives the permission, that is either read permission, write permission, execute permission. The permissions are also depend on the owner, depend on the others, depend on the group. Then next is your reading and writing a file. So till now we have covered how to open a file and how to close a file. Open is or opening a file is indicated by using the open function. That is, open function is used for opening a file and the close function is used for closing the file. Now next part is how to read and how to write the files in the Unix input or Unix system. But before this, let's take a quick review of the opening and file. That is how to open a file. This informs the kernel that you are getting the ready to access that file. This means whenever we open the file, that is a responsibility of the operating system to inform the kernel that you are getting ready to access that file. This is the same example using the fd as a variable, then uses the open function. This is the file name, this is the read only, this is the error condition, then exit 1. Returns a small identifying integer, that is a file descriptor. That is fd is equals to 0 indicates that there is an error that occurred. Each process created by the Unix shall begin life with 3 open modes, 3 open files that is associated with the terminal. That is standard input, standard output and the standard error. So 0 indicates the standard input, 1 indicates the standard output and the 2 indicates the standard error. Then next is your closing a file. So one is opening a file by using the open function. Next, closing a file that informs the kernel that you are the finished accessing that file. Again using the same variable, that is int fd, int ret value, that is the return value. This is a file descriptor. Then uses the condition, uses the if condition, that is if the return value is equals to close fd. That is, if it is a close fd, that is the file descriptor is closed, that is no usage of the or there is no more content, then gives the p error, that is a close, and then exit the 1. Closing an already closed file is a recipe for disaster in the threaded program. That is discussed in the later stage. That is, whenever we close the same closed file, that is also a error, that is also a bug. The moral is that always check the return codes even for the seemingly begin functions such as close. This function is used for closing a file and open function is used for opening a file. Next topic is reading and writing the file. But before this, let's take a 5 to 10 minutes break and then come back starting with this topic, that is reading and writing the files. So let's take a break for 5 to 10 minutes. Now let's start with the next topic, that is reading and writing the files from the in the Unix system. That is how to read and how to write the files, or how to read the files from the Unix input output files, and how to read or write the files, and how to store the files, write the files into the Unix input output. That is the writing the files in the Unix, or the writing the files in the input output. That is reading and writing the files. This says applications perform input and output by calling the read and the write function. That is, application performs the input and output operations by using the read and the write functions. This is hash include uni std.h. That is using the file, that is a uniform standard input output, or the uniform standard.h. This is the header file that contains uniform functions that is used, that is a read function, write function, open function, close function, that is used for giving, or that is used for the input output operations. This says size t that is s size t read. This is a read operation that is used for reading the file. There is a fd, that is a file descriptor, then void buffer, then size t n. These are the argument that is used for the read operation. That is, first of all, check the file descriptor, that may be negative, that may be positive, that may be 0. Then using the buffer, that is void pointer buffer, that is a pointer variable. Then using the n variable for counting the number, that is in terms of the counting, that is a size t. Then it returns the number of bytes read if okay, that is it returns the number of bytes that is required whenever there is a read operation if the code is okay. 0 on the EOF, that is 0, or 0 on the end of the file, and -1 on the error. So if there is any the file descriptor reaches to the 0, that is end of the file, so it gives the output as a 0, and -1 on the error, and return the number of byte that is in size if there is a, or that is a valid code, or this is the okay code. Then next function is the same function, that is s size t read write. So one is read, one is write, that is used for the writing the files. Then int fd, that is using the int variable. Fd means file descriptor. Then constant void pointer buffer, then uses the constant variable, that is constant for writing, that is a void pointer buffer. Then size t n, that is using the size variable, uses the n variable. Then it returns a number of byte that is written if okay, and -1 on the error. This is the read function copies at most n bytes from the current file position of descriptor fd to the memory location buffer. That is, it reads the operation, or it copies the, or the read function copies the operation of the n bytes to the next point, to the next level that is used for the operations. A return value of -1 indicates an error, as I told you, and 0 indicates the end of the file. Otherwise, the return value indicates the number of bytes that were actually transferred, that is in terms of size. So this is the read and the write operation. This is the figure that copies the standard input to the standard output 1 byte at a time. This is the hash includes cs application, that is the cs application.h, that is the header file. Then int main, that is the main file that is used. Then void, then uses the variable, that is a char c, that is a char c. Then uses or using while operation, that is a while operation, read stdin file number c1 not equals to 0. Then this is the condition, that is this is you read the operation until it reaches to the 0, that is until it reaches to the end of the file. So reads the file until we have reached, or until the program reaches to the end of the file, that is stdin, that is standard input file number %c1 is not equals to 0, means read out the operation till file reaches to the end of the file, or the cursor reaches to the end of the file. Then write the operations by using the std out, that is using the file number, same variable is used, that is %c, then 1, then exit the 0. This is the example of copying the input to the standard output 1 byte at a time. This is 1, %c is the character, that takes 1 byte. So it reads the data and transfers the byte to the standard output 1 byte at a time. Why 1 byte at a time? Because char takes 1 byte and we are using char c. So it takes 1 byte, accepts the data, passes to the standard output, then copies 1 byte, passes to the standard output. The write function copies at most n bytes from memory location buffer to the current file position of the descriptor fd. So that is the write function that copies at most n bytes from the memory location buffer to the current file position of the descriptor, that is the fd. Figure 2 shows a program that uses the read and the write codes to copy the standard input to the standard output 1 byte at a time. Most application can explicitly modify the current file position by calling the lseek function. which is beyond our scope, that is which is not in our course, that is how to use the lseek function. Now, in some scenarios, read and write transfer few bytes than the application requires. Such shortcuts do not indicate an error. They occur for a number of reasons. Why? In some scenario, fewer bytes or read and write transfer fewer bytes than the normal request. Such short command do not indicate an error. They occur for a number of reasons. Why? What are the reasons that is available? Sorry, that is encountering EOF on reads. That is why read and write transfer fewer than the application needs or than the application request. The main reason is that whenever there is a condition that whenever the EOF or the end of the file or the cursor reaches to the end of the file, that is encountering an end of the file on the reads. Suppose we have already or we are ready to read from a file that contains only 20 bytes or 20 more bytes from the current file position, and that we are reading the file in 50 byte chunks. Then the next read operation will return a short count of 20. Why? Because we are able to read the 50 bytes, but we contain or we are supposed to contain or we are ready to contain only 20 bytes, and the read after that will signal end of file by returning a short count of 0. This is the condition why the read and write operation or operation transfer the fewer byte than the application request. Next main reason is that reading the text line from a terminal. This is also a next line. If the open file is associated with the terminal, that is if the open file is associated required with the terminal, that is if the open file is linked with the terminal, that is keyboard and the display, then each read of function will transfer one text line at a time, returning a short count equal to the size of the text line. Then reading and writing network sockets. Next is also this is also a condition. This is also a reason why input output transfer less bytes than the application request. If the open file corresponds to a network socket. What is a network socket? That contains multiple computers in which a socket in which we can connect or different computer wires that are connected in a what? Socket. If the open file corresponds to a network socket, then internal buffering constraints and the long network delays can cause the read and write operation to return the short counts. That is, if there is a network buffering, if there is an internal buffering constraint, that is my network speed is very slow. The best example is that my network speed is very slow. Then in such scenarios also read and the write operations, read and the write networks also delays or read and the write operations also transfer few bytes than the application request. Short counts can also occur when you call read and write on the Unix pipelining. That is the inter-process communication mechanism. That is your not in your course, that is beyond your course, that is Unix pipelining. These are the various reasons why there is a short transfer of why fewer transfer of why the few bytes are transferred than the application request or then what the application request. In general, in practice, you will encounter short counts when you read from disk file except on EOF, and you will never encounter short counts when you write to disk files. However, if you want to build robust, that is reliable network applications such as web server, then you must deal with short count by repeatedly calling and read and write until your bytes have been transferred. These are the various points why there is a few bytes of transfer than the application request. Now let's see with the help of PPTs. We have studied about closing the file. This is opening the reading the file. This is reading a file copies bytes from the current file position into the memory. As I told you, what do you mean by reading? That is transfer the file from the or transfers the byte from the current file to the memory. That is transferring the file to the memory so that memory can process the execution and then gives the result. This says reading a file copies bytes from the current file into the memory and then update the file position, that is a file descriptor. So this means copying the bytes from the current file position to the memory, that is a reading. This is the example of the reading, that is char buff 512, that is using the buffer variable that contains 512 bytes. Why 512? Because char takes how many bytes? 1 byte. Then using the descriptor, that is a file descriptor, that is a int fd, that is in terms of integers. Then int n bytes, that is a number of bytes it can read. Then open file fd, that is opening a file, read the file up to 512 bytes. So this says if n bytes, this is the variable that is used, this is the n bytes, is equals to the read, that is if it is equals to the read means reading the files or copying the data from the current file to the copying the bytes from one current file to the memory, that is a read fd buff size of buff, that is using the fd file descriptor, buff, that is a buffer, then size of buffer. If the read operation is greater than 0, that is it does not reach to the end of the file, then p error, then gives the error, that is a read operation, then exit 1. It returns a number of bytes read from the fd into the buff. So it reads the file or returns a number of bytes into the buff variable, that is it returns number of bytes, that is a size of buff. N bytes is greater than 0 indicates that an error occurred, that is if it is beyond the end of the file, then the error occurred. Short count is when the n bytes is greater than size of buffer, that is if the size of function gives the byte more byte than the it gives the short counts are possible and that are not errors. So this is the same that we have studied with the help of the book. Then next is your writing the file, that is how to write the files. The read operation is performed by using the read function and the write operation is performed by using the write function. So this says writing a file copies the byte from the memory to the current file position and then update the current file. That is whenever we write the file that copies the bytes, that copies the byte from the one location or from memory to the current file position. And then update the current file, that is copying the data in reading, copying the data from the it should be less than, that's why I'm asking, that's why I'm saying that it is less than or it is not beyond the end of the file. If by mistaken I'm saying greater than, so it's so sorry, but it is less than, that's why I'm saying that it is below the end of the file. It's okay. Where I've the read operation is performed by using the read function. In the same way, the writing the file is done or is performed by using the write function. So the same example is here. In reading, the copies the byte from the memory to the from the file to the memory. In writing, copies the byte from the memory to the current file position where it is required and then update the entries in the file. This is the main difference. In reading, copying the byte from the files to the memory. In writing, copies the byte from the memory to the file. Then this is the example, that is char buff 512. The same example, fd, that is a file descriptor. Then n bytes, that is a number of bytes read, uses the n bytes. This is less than 0, right? That is the cursor or the pointer does not reaches to the end of the file. Then uses the write operation, that is transferring the byte from the memory to the file. then uses fd buff size of buff. Then if this is less than 0, it's okay, otherwise it gives an error, that is the p error, right. Then exit 1. This says returns the number of bytes from the buff to the file fd. If it is less than 0, that indicates an error occurred. As with read, the short counts are possible and not the errors. Transfer up to 512 bytes from the address buffer to the file fd. Now next is the examples. Till now we have covered reading, writing, opening, closing. Now these are the various examples. Copying standard input to standard output 1 byte at a time. This is the example how we can transfer, how we can copy the standard input to the standard output 1 byte at a time. First of all, including the header file, that is cs application or cs app.h. Then uses the int main void, then uses the variable that is a c, that is of char type, then uses the while function, uses the while statement, that is uses the read. First of all, that means read the file, that is the standard input output file, then file number %c, that is it takes only or it copies only 1 byte from the input and transfer 1 byte to the output, not takes 2 bytes, not take 4 bytes. Why? Because I am using the char c, that is the %c. If that is not equals to 0, that is not reaches to the end of the file, then write to the file, that is till where we can stop, till it reaches to the end of the file, till it reaches to the 0. Then write std out, that is standard output file number %c1 exit 0. Note that the use of error handling wrappers for read and write, that is these are the error handling wrapper that is available for read and the write operation. This is not in course, but this is the example, that is first of all check or first of all reads the byte and how long the computer reads the file until it reaches to the end of the file, and then writes the same bytes to the by using the write operation, that is 1 byte is read, 1 byte is transferred, that is written. 1 byte is read, 1 byte is transferred, that is written. 1 byte is read, that is byte from byte or byte to byte, it is read from the memory and write to the memory. Now how to deal with the short counts, then how to deal with this content, that is a short count. Next is your how to deal with the short counts. Remember what is the short count? That is whenever the Unix transfer the less bytes than the application request, that is a short count. So how to deal with the short counts? This says short counts can occur in only these conditions, in these situations. What are the conditions? That is encountering end of the file on reads. So short counts can happen whenever there is a end of the file, that the cursor reaches to the end of the file on the reads. Suppose for example, if the document that is searching or that byte that is transferred contains 30 bytes, right, and it means that after 30 there is an end of the file, and short counts can occur or can incur within the 20 to the 25, that always or that occurs or that deals or that continue with till 30, and at 30 there is an end of the file. So that shortcuts or that short counts becomes the short counts only. Becomes means that is available to the short count only, because that is recommended or that is punching at the 20 to the 30 location, but beyond that there is a end of the location, end of the file that has occurred. So that is also encountered, or that is also occur whenever there is a end of the file on the read. Then next says how to or how short counts occur whenever we read the text line from a terminal. This is also a scenario whenever we read, or whenever the computer reads a text line from a terminal, from the keyboard, from the mouse. That is also when the short counts can incur, or that is when the short count can occur. That is whenever the computer reads the text line from the terminal. Terminal may be computer, terminal may be keyboard, terminal may be mouse. Then the next scenario, whenever we read and write the network socket or the Unix pipeline. These are the three scenarios, three conditions when the short counts can incur. So first of all, whenever there is an end of the file, then whenever we read the text line from a terminal, then read and write the network sockets or the Unix pipeline. Then next is short counts never occur in these conditions or situations. First of all, we have studied this occurs in these scenarios. Now this never occurs in these scenarios. Reading from disk files except for the end of the file. That is, whenever we read the data from the disk file, that is except or when we separate the end of the file, that is reading the disk file, reading from the disk file, that is also a condition whenever also a condition when there is no short count. Why? We read the data from the, or the computer read the data from the disk file directly, that is except for the EOF. Then next is writing to the disk file. So it means the short count the short counts never occur whenever we read or whenever we write the data from the or to the disk files. Then next is, or the next point says, how should you deal with the short counts in your code? Then the solution is that uses the RIO, that is your robust input output package from the text box, that is cs application.c file. This is the technique, this is the method how to use the CS application, or how to deal with the short count, that is using the RIO, that is the robust input output condition. Now let's start with the RIO package. This is also the RIO. This is a new topic and there is no time left. So let's start with some introduction, then stop over here at 550 till from the IST. So let's start what is robust or the what is RIO. That is robust reading and writing with the RIO package. That is how to read and write the data, or how to read and write the bytes with the use of RIO. That is a robust input output. Why? Because to deal with the shortcuts or the short counts. In this section we will revise, or we will develop an input output package known as the RIO. Means in this topic we develop, or we will develop an input output package, that is a robust input output. That handles these short counts for you automatically. That these short counts will automatically removed by using the RIO, that is a robust input output. The RIO package provides the convenient, robust and efficient input output in applications such as network programs that are subject to the short counts. So this line says this package, or the RIO package, provides the convenient way, provides the robust way, provides the efficient input output operations, input output applications such as network programs that are subject to the short counts. RIO provides two kinds of function, that is it provides two kinds of function. One is buffered input functions, one is unbuffered input and output function. So one is buffered input one is only buffered input, one is unbuffered input and output functions. So in simple terms, whenever we have to deal with the short counts, we are able or we are mandatory to use the RIO package, that is robust input output package. And there are two techniques, there are two kinds of functions. One is unbuffered input and output, one is buffered. These two topics I will be starting in the tomorrow's class, but I'm not stopping over here. Let's take a quick review about the slide, but let's stop over here with the help of the book. This is the RIO package. This is a set of the wrappers that provide the efficient and the robust input output in application such as network programs that are subject to the short count. The same line, RIO provides two types of function: unbuffered input and output, that includes RIO read n, RIO write n, that is a write n and the read n. Then buffered input of binary text and the text file, that is using RIO read line and RIO read NB. So these are the two functions that is using or that is included in the RIO package. So these two functions I will be starting in the next class. So that's all for today's session, because no time is left. This is a long topic that is not covered in the today's class. So that's all for today's session. Let's take a quick review what we have covered in the today's class, and then if you have any doubts, then please text that doubt and I will answer you. So let's start with the first one. We have started with the chapter number 10, that is the system level input output. These are the topics, and today I am covered with these two topics only, that is the Unix input output and the robust reading and writing. We have studied about a typical hardware system. This is the diagram of a typical hardware system. Then there is a CPU chip, there is a input output bridge, main memory, disk controller, graphics adapter, USB controller, exceptions, slots for other devices such as network adapters. These are the this is the diagrammatical representation that we have studied, that how typical system hardware builds, or what is the scenario or what is the scene of the typical hardware system. Then we also studied how to read a disk sector, that is how to read the data from the disk. These are the steps that we have studied: step 1, step 2, step 3. Then we have studied about the Unix file, that is what is a Unix file and what are the types of Unix file. That is a collection, that is a sequence of m bytes. These are the types of the Unix files, that is the Unix file types. One is regular file, one is directory file, one is character special and the block special files, one is FIFO, one is socket, that is used for the network communication. Then Unix input output, that is we have studied what is the Unix input output and what are the operations that will be performing in the Unix input output. That is we have studied open, close, change, read, write. These are the few operations that is performing, or few operations that is performed or that is performed in the Unix, that is the Unix input output operations. That is also known as the system call. So whenever we say input output operation, that means we are saying about, or we are talking about the system calls. Then first is opening and closing the file, that is opening is done by using the open function, closing is done that is using the close function. Then changing the current file position, that is the lseek, that is not discussed. Why? Because it is not in course. Then reading and writing a file, that is reading is done by using the read function and writing is done by using the write function. Then we have studied how to open a file and what is a file descriptor, what is the output, that is input, output and the error. Then we have studied how to close a file, that informs the kernel that you are finished accessing that file. That is closing a file. And one of the important concept is that closing an already closed file is one of the disaster, is one of the error that is occurred in the threaded program. Then we have studied how to read the file. Whenever we read the file, there is a difficulty of the short counts. That is, reading a file copies the byte from the current file position to the memory and then update the file position. Then we have studied how to write the files. That is, writing the file means copying the byte from the memory to the current file position. Then this is the example that we have studied. This is the best example that copies the data from one byte to the next byte. Then how to deal with the short counts, means what are the techniques that is using, that how to deal with the short counts. In this we have studied why short count occurs, or what are the scenarios in which short count occurs, and what are the scenarios in which they do not occur, and how to deal, that is using the RIO. That is a RIO package. That is a next class topic, that is a tomorrow's topic. So that's all for today's session. Now if you have any doubts, then please text the doubts and I will answer you. And tomorrow's class I am taking your next topic, that is a RIO package in detail. So that's all for today's session. Thank you so much everyone. If you have any doubts, then please text the doubts.